So we have 6 teams for the problem 2. Is that correct? I'd like to find out what machines and systems the teams are on. So first of all, John, you and
Amy
and Andy.
What are we on now? Diablo?
You'll be using a VAX?
Yeah.
Okay.
We'll be on a VAX as well.
All right. And you and
Neil.
you and Anil?
I'm with Andrew.
And Andrew and Anil? No?
No, wrong. I thought you were
No,
both.
I'm sorry. Okay. So, and you're on?
Andrew Golding and I are working on the VAX.
On the
At
VAX?
the moment, we're hoping to get a Navajo account.
Okay. And Roger?
Working with Anil.
Either VAX or
Either, yeah.
Okay, you don't, okay. Either VAX or SCORE. And then John?
VAX with Karen and Rich.
And Rich. Okay, so that's all about the same. Amy, you're already accounted for. Marianne?
I'm working with Kathy, and at the moment I have the program on a 20. I can probably move it onto a VAX if that's what
Doesn't
everyone else
matter.
is using.
No, it doesn't matter. I
Okay.
think we'll be able to use any Ethertip
Yeah, right.
connection. Okay.
I'm running out of money on my Square account.
Yes. Well, that's a fixable problem. Yeah.
Okay.
Okay. They say it's fixable.
Right.
Okay. But it's on SCORE and okay. That's 5, I think. Who's left? Arif? Sumex. Okay. So that's easy to get to from Ethernet too. Okay. So nobody's working on SAIL. Okay. Is that so? We don't need a data disk terminal. Now, okay. Now you know the exciting new change in the plan, namely that you have 12 hours less to finish your programs. However, it'll be quite symmetrical between every group. Namely, everybody will start out and we're going to give you 50 minutes to solve this cryptogram, and it'll all be videotaped for each team, and so we'll be in some kind of isolation booth, just the team and the cameraman and me, the referee, and then at the end of 50 minutes, next team comes in and we start the same thing going, and we'll have 6. So we'll have 6 50-minute sessions. Which makes 5 hours of videotape, which we will then, behind the scenes, boil down so that everybody as a group will be able to see the highlights of the major aha insights that were that developed in each session, and of course a suitable prize will be awarded to the team that gets the cryptogram complete first. And speed is the name of the game. Although of course we'll also want to enjoy what?
I like correctness.
Correctness. Yeah, well, that's right. The correctness of solution. Yeah, and I think I did tell you that it will be an English language text cryptogram that yeah. Okay. Now, as far as I guess if we just find some office in Jack's Hall sufficient to hold a camera and 3 team members and me, that we don't need any other equipment. I mean, sort of a random terminal will work for all of your programs. Is that correct? A Xenon, for example. One of the cheapo terminals. As far as anybody knows, it'll work okay. What?
Not too cheap.
Not too cheap. I mean, one of those that exists in quantity in the building. Yeah. Okay. In order to do this, we'll have to adhere to a time schedule, and so I would like to make sure that before you leave today, we get the time schedule for next Monday all nailed down. We'd like to do it all between 3 and 5 p.m. if possible. All right, now
3 and 8.
3 and 8.
Well, if you got more
What did
than
I
one
say,
camera,
3 and 5?
It's more than one.
I was just
camera.
taking the difference. Fibonacci numbers are all the same. Okay, between 3 and 8 p.m. Okay. Now, the things we talked about last week were probability and interaction, and I guess the mixing of the two is the next thing. But we need some ideas in order to get better speed, probably. I think the ideas we had last week would be enough to solve the thing in a couple hours. But we need something that will get better. We'll get good speed, perhaps. Maybe you guys already. Maybe the ideas that have already been mentioned are enough. Now, can I get anyone to talk about their methods now that you know that you're in competition with each other? I still think that it's possible to be friends and talk. What do you think what do you think is a good way to proceed as far as what are the bottlenecks in the speed? Let's put it that way. What's going to take time, and how can we avoid it? Comments on this from anyone? I'll let you say.
Maybe you're trying to come up with the words of the English text.
Mm-hmm. So the hard thing will be to guess likely words. Okay. So for that, having 3 people on a team might be a little better than having 2 people on a team. Is that right? So somebody just thinking of a word. Now, how are we going to think of a good word? What would be aids for thinking of probable words?
Dictionary.
A dictionary, okay. Right, it's not much of a plot, but what a vocabulary. Okay, so open up a dictionary, and that would suggest, no, I think there's a better way. Karen?
If you had some really specialized dictionary that was not indexed just by first letter, but by, you could index into it by all words that have an E in the
Oh, like some of the crossword puzzle dictionaries. There seem to be 2 kinds of crossword puzzle dictionaries in the world. The one is the kind that I think Dell or somebody that will give you all the 5-letter words that have the second letter is a U and the last letter is an E.
Oh, I've never seen that.
You ever seen one of those? Yeah, and it's possible to there is a pocket book like that. If you really have to solve a crossword puzzle, and this is your last resort, and this is one. But unfortunately, most of the words in there seem to be words I never heard of. But I guess that's true in crossword puzzles too. In cryptogram, we can expect that these words aren't going to be too unusual.
Yeah, I know there have been studies done about the frequency of words in the English language and which ones are most common.
Okay, frequency
so
of
like
words.
that could come in handy, looking for those words instead of obscure ones.
Okay, so for example, one of my own books, in fact, uses as an example of a database is the 31 most common words of the English language. In volume 3 of Sorting and Searching, I made some search trees based on frequency of the most common words in English language, and the wins, and after that there are a few others, that, which, some long ones. Okay, common words that way.
The problem with that kind of thing is that, especially if the word is short, as I think common words in English frequently tend to be,
yes.
they tend to occur in so many places. I mean, those are the words one uses mainly when one is starting off, and there are few constraints, if any. And at that point, you can get a bit too many of them.
Okay. Let me ask another question before we continue this. How many people know what are in the first and second message on the thing? So that's representatives of. Okay. How many do not know yet what that is? We got about half and half of the group. So. Okay. All right. So we can't really base the the thing on this, but one of the main things I can mention, the reason I brought this up is that as you prepare for next Monday, you'll be able to, you should try to take something that you know how to decode, just so that, but pretend that you don't know how to decode it, and then you can see if some of the techniques that you've developed for speed would actually have helped you. In other words, you have hindsight. In part of your mind, you try to forget that you have this hindsight, that you know what the answer is. But in the other part, you say, now here's something that I would reasonably propose, and would the machine help me focus on a good direction or not? Also, I have another cryptogram if you need to try your method on. Where is it? Oh, okay. I'll show you later. It's on sale. Cipher.3. That's the one that I took out of Wuthering Heights. But there's another way to get probable words, maybe, that some of you might have noticed if you on the work you've done so far on this thing.
Well, if you have partial things, and then you find out what are the possible things which could go in there.
Okay. In other words, you're sitting there with a partially decoded message, and you see some letters up there, and this might suggest something to you. Okay, but now without a dictionary, like Karen's suggestion.
I didn't mean just that.
Yeah. Now, if the computer could do this, but really, maybe our own brains are good enough too at this kind of retrieval. In fact, even better probably at partial match retrieval. It seems to me that this is something that distinguishes the human brain from the computer brains. Is the way we can more easily retrieve facts from partial. Somebody's grown a mustache and we still recognize his eyes. Computers don't seem to be able to do that very easily compared to us. So that's the case. Okay, now let's see.
The problem is it doesn't help you to get started.
It doesn't help you get started. Okay. So now, does anyone have an idea for how to get over the first hurdle? Once you've got half of it, then you think you can fill in the others, and it's a matter of getting a critical mass of the solution going. So what's the first thing that you would try if you're going to solve one of these cryptograms?
Frequent words that have what we call the program property, 2 letters that differ by the appropriate amount. The more occurrences of the program property in the word, the fewer chances that it could be matching by accident. Okay,
that's a good point. That that this property that we had last time that you said about half of the words in English satisfy, the chance of false drops, false hits, seems to be smaller on those because why?
Well, for instance, if you just have one match of the program property in consecutive letters, then there are only, you can only have it for 26 pairs of letters there. And then if you have it again, then you have to take the intersection of those 2 sets. And you keep taking intersections and it keeps getting smaller.
Okay, so in some sense, the fact that we're using the same part of the f function, of the unknown f function, instead of different parts, is giving us, and as well as the fact that we're getting 2 confirmations of the same part of the f function. It seems a little more reliable. I did learn something that impressed me as I was working on this myself, and that is I found where I was afterwards, after I made a mistake, I tried to say, well, how had I gone wrong? And one of the things that I would put in, say, an 8-letter crib, including a space at each end of the word. So I had a 6-letter word and I put spaces before and after, and I got a hit. And I said, oh gosh, 8 letters in a hit, that's pretty convincing. Well, it turned out that only 7, that one of those spaces was really a semicolon or a carriage return or something else. It's a punctuation mark. And the thing that occurred, that I realized then, was that 8 letter hit is pretty impressive, but it isn't that much stronger than 7 letters followed by another asking, is there a space after the word? And a space after the word has a probability of about 30 or 40% of being there, of working anyway somehow. I mean, there's a chance of that the things even though you have a long hit, there's still a chance that individual letters of that hit might not be too reliable. But you don't have to believe something just because the total event was improbable. It's still mostly improbable, followed by one probable, or some. I don't know how to do that algebra. Okay, so any ideas on how to get going, how to get started? Besides that, so that's one of them. Try English words that have this property. What's a good one? Well, ing, someone mentioned. Any word, any, just a suffix ing.
T-I-O-N ending.
T-I-O-n, that has
the O-N.
The O-N in it. Okay. Shun is another. So in other words, suffixes, not full words, is another. Fragments of words is another possible win. Okay. Now, okay. Let me see. Does any of you have a program that I could telnet to and try on my new cryptogram to see what it would do?
You could look at my program.
I can use yours?
Yeah.
It's on Score?
Yeah. I've been running it on CSLI, but there is a copy on Score because I've moved over there to print it.
Okay, well, let me try that just to see if our computer thing gets going. We'll see. I mean, I want to try out this machine just to see if we can actually do anything. Okay, so Score?
Yeah.
You better log in.
Yeah, probably a good idea.
You guys will be able to watch it on that monitor up there if everything goes well.
Hit it, Ramsey.
It is. Oh, well, let's first hide it. Okay. No, we're not going to get a password on the screen. It's okay. It'll be. It's not going out there. Okay, it's going now. I'm sorry. At least I hid you from the other sale users. Oh, I got to bring over the file. Yeah.
Oh, no,
Yeah.
sorry.
Okay, I'll bring over a file first. Let's Control C, I guess. Let's see. There's some kind of a. No, I know. Control C is a. Is there. Okay. Now there's some kind of a transparent mode that I don't remember how to get. So let's hope it's good enough. Okay. FTP cell. Okay, now let's see. Get login. This is no good. Okay, so now get cipher 3. Cipher 3. Okay, so quit. All right, now get going. Okay, this cipher number 3 is it was taken from near the beginning of Wuthering Heights, a novel. Does anybody know this novel by? What? What? By heart?
I have to get English words over from CSI so I can use this program.
Oh, okay. Okay, so it's by, oh gosh, what's the Bronte, one of the Bronte sisters, huh? And, what? Charlotte, Emily, yeah, right, okay. And this was just to give us some ideas as to what you might be faced with next Monday. Well, yeah, we'll try to generalize from these experiences. And while you're working on this problem, I should also mention, keep in the back of your mind what are the key things that make it succeed for you, so that if you were designing a better crypt command for Unix, what would you do that would defeat all of the things that we're doing here?
You know something, if we get this thing running really well, we could maybe even get the Unix people to put it in as a program for decrypting things.
Yeah.
You think they would?
Yeah, that's right. The users group would do this. Well, yeah. Of course, we should encipher it first. Okay, now, Kathy, what? Okay, we can't see you because your shoulders are in. I didn't want your password to be showing all the time. Okay. So we can see a little bit here that she's running something called decrypt. Input is in English.txt, okay?
That file contains a lot of English words.
Okay.
The first thing it does is goes through and just pairs of letters.
These look like a combination of Pascal and English, and so that you can use the same program on both. Is that right? Do we have somebody has an almost procedure, for example? Huh? Yeah. Okay, so it's called cipher.3. Okay, now what? Okay, help? Okay. All right. Okay. So, print decrypted text so far, add a guess to F, guess a word, print the current map, undo a previous guess, print the cipher as text, add a word, and begin guessing from the start again.
Yeah. The begin guessing from the start again just means that you start looking for words with letter pairs from the beginning of the text. Okay.
All right. So let's type something now, huh? B.
Well, try guessing the word.
G. Guess a word. Okay. So it's suggesting a word for you. That's the idea. Okay. See that we still have our base 32 arithmetic in here. Yeah. I really like Ramsey's idea to use letter codes instead of numbers that you can, as long as we, yeah.
The reason there are numbers there is because at the moment it takes its input either in the form of coordinates, where you give you see the numbers down the right-hand side of the screen, give it in form of coordinates.
Right.
Or you can just give an absolute number.
Yeah.
Okay.
Yeah. What I was thinking is that a decimal or octal or any other number system isn't really critical as long as we have a one-to-one correspondence. Okay. So now look at that. We have already found. Is that a dollar sign?
That's a dollar sign.
In this message?
Well, that's one of the visible characters that we're allowed to have.
Yes.
But it seems unlikely that it would be an English text in that.
It wouldn't probably. A pound sign would be more likely, but in the Brontes, yeah. Okay, but explain what happened then. You typed only a G, and it already put in a few of these things. So what is the?
Okay. What it did was it started at the beginning of the cipher text, and looked for letters which were one at a time. You know, the way it was done with the program where you had letters that were 5 apart.
Right.
Okay.
Right.
So it compared those to the list that it had in its dictionary, which was the first output you saw there. And the first one that it found was have in that position.
I see. And this is and this entirely is a consequence of putting have in that position.
That's right. Yes.
Okay.
And you can undo that. And then ask.
Oh, okay. So now, but the fact that it also showed up a $, it makes it unlikely, because that $sign was only a consequence of have. Okay.
That's right.
So it might have been save or something else,
okay.
having or
do
something.
that.
Okay.
And it tries another one.
Okay. And this one is
It found nil.
nil. What?
As a consequence, it found
Nil. Okay, this is a Pascal program. Maybe I've given you the wrong text file here. Yeah.
As a consequence of finding nil, it put an F after it. Okay. Which means those. Okay, so that seems unlikely as well.
Well, yeah, but this reminds me that our new department chairman is the plural of nil. Okay.
Okay, so try something else.
Except he's probably a capital.
You're the opposite. Anil. Anil is the antonym. Anil. Okay, make with what is this? A comma, a period?
That's a comma.
Well, that's reasonable. Texts do have commas in it.
Yeah, okay, so that's all right.
So that one looks okay. We got H and E in here.
What's the word it found? Make?
Make.
Make.
Yeah, this says make, believe it or not.
Put a space in front of that.
How does it decide which word to try fitting in?
It finds a letter pair, then it tries all the words in its list, and any which would be impossible because of invisible characters or clashes with things that are already there. It discards. So make was the first one in its list that didn't clash with anything.
Before we go on, does anyone have an idea how we could already use the example that we've seen so far to speed up what we've done? I mean, but you know, suppose you had this program already. How could you change it slightly to maybe make it go a little faster?
Also look for unlikely English characters.
Unlikely things like $ and things like that could also be, in other words, there could be some kind of a probability added to this, saying that it's legal but not as probable. And maybe some kind of a rank ordering could be computed before it presents the answers.
Yes. The other change that I would like to make is just change the list of words which I give at the beginning. Just something I thought of doing, but because I haven't really looked at the program today or yesterday, I haven't done it yet. But it would be good to change the list of words so that what it was looking for things like ing rather than complete words.
I see. Yeah, but the fact that a $ flashes up was a pretty much of a giveaway to us. Although there are some characters that are you know, like suppose it was a number 2 or something like that. Okay, well you can use 2s. You know, punctuation marks they do occur, exclamation points, so on. They aren't in your usual frequency counts that you get when you just consider frequencies of English words. But you know, and spaces are also something to take into consideration. But there's some kind of a plausibility index that says, well, yeah, this could be, but you know, you don't want to rule it out absolutely impossible, but still it's rather unlikely. And we should talk a little more about that. Okay, we're getting close-ups here.
Another thing that might help, at least maybe not so much in the early stages of the game, but later on, is when it puts a word in, maybe have it highlight the characters that appear as a result of that particular insertion.
Okay, something flashing or something, some way to focus attention to the consequences of what you just did.
Yeah. The fact that
if there's a way to do that. So a way to get visual cues. Okay.
That would be
The
nice.
thing
Go on.
is
Yeah.
It's not easy.
It's not easy in some programming languages.
Well, this is Pascal,
Yeah.
but it would involve knowing more about the terminal, I think, to do it. There doesn't seem to be any libraries around that I know of. If anyone knows of any libraries that would let me do this easily,
With Pascal, you mean?
with Pascal, yeah.
Well, I didn't mean anything fancy like inverse video or anything, but I mean just like print an extra,
Maybe
How did
underline,
it do
underscore it, or something like that.
Yeah.
That would probably make it harder to
Yeah,
read
it's,
the whole thing.
No,
okay, so, yeah, there might be a way to think of a way to highlight it, even with Pascal, but not maybe as compact as we have here. Yeah, so, you have 2-character code though, so it might be possible to do that somehow.
Yeah, I'm not sure of the way at the moment.
It's not, yeah, and it's not clear exactly how much some of those things will. At this point, it's easy for us to see because we have only one part, but maybe after things get going. Okay, so it looks like we have a make in the middle there. That's
Okay, so you want to leave that there?
yeah. Let's try it. Let's see what else it does here.
Now, it goes back to asking what to do. What I found decrypting your previous messages is that the nulls tend to be at the end. So what I would do next is to try looking for nulls at the
Okay,
end.
let's look for nulls.
Okay. So I do that by typing A for adding a paragraph.
That's par for the, that's fair game to look for nulls at the end.
Okay.
Backslash
0. You can specify your
0.
ASCII value.
Where does it go? Okay.
Okay.
And
Now,
here you want to say 255. Huh?
yeah, I've included the absolute.
Mm-hmm.
Right.
Okay.
And null at the end.
Okay. Yeah. The reason is that I took this out of the middle of a page with Wuthering Heights, and it doesn't. It's not the same as the other message was a complete page by itself.
Yeah. Okay.
And a page in the editing system that I was using is filled out with nulls at the end if it's less than 256 characters. Okay,
So try something else.
that would have been a good idea for the message for the ciphers that you had in class, but
Yes, it helps a lot.
but for Wuthering Heights, we might be in the middle of a word, in fact, at the end here, because this is just taken out of the beginning of the middle of a file.
Okay. Next thing I would try to look for some spaces.
Mm-hmm. Okay.
What would the space?
I really appreciate your being a guinea pig for us, Kathy. That did help.
Put a little space after the comma that's up there because it seems likely.
Okay. What else would go after a comma? By the way, group. Besides carriage return, yeah. Anything else?
space.
Space, carriage return. In a Wuthering Heights, no. What else? Quotation marks. Yeah, I think that would be. That would be about all we would expect there after space, after a comma. Is this okay? It seems to have been okay.
Yeah.
All right, did that give us any more letters?
I don't think so, no.
What's on the bottom row there?
There's the question. You can answer that with something else.
It might also be useful if it could tell you which positions you're most likely to gain by guessing about.
That requires quite a bit of.
Okay, so a look ahead to say how many places it really affects is really
Yeah, how many times that F value occurs.
that value occurs. Okay.
It might also be nice perhaps to be able to say how many possibilities are there for a given space, for a given place in the ciphertext, but that again requires a reasonable amount of computation.
Not really too much.
Well, there's a balance between compute time and yeah. I mean, supposing that we increase the amount of money in your accounts sufficiently, there's a certain balance at the other end too on how much compute time you can spend. But we're trying to get fast. Yeah. Sorry.
I thought this is essentially a constraint satisfaction problem.
Constraint satisfaction problem.
I mean,
Yes.
essentially you have a function f which you have to satisfy, and you have a set of constraints, and also the constraint of reasonableness, which presumably I doubt we can program into it, but
Okay.
that's something which could
All
be
right.
checked. And there exist systems which will very efficiently work out constraint satisfaction problems for you, very complicated. For instance, there is a system called Alice.
Alice.
Yeah.
Yes.
By Lauria. And of course that I don't know how well it would work for this kind of constraints, but which has been shown to work very well for general problems, constraint satisfaction problems. So in theory, if one were really working on it, one could even try to use.
So it's Alice is running at SumX, and you could
if
could
it
tap
were-
into, it's, it wouldn't be out of the question to use someone else's program in a creative way in this course, I guess. But constraint satisfaction, that's everything. I mean, that's building bridges. That covers everything in the world.
That's
What, you just put in your constraint, and Alice.
So it finds a solution, and presumably one could add in some code which would also ask you whether, as a constraint, whether the thing was reasonable.
And
But I'm not sure what it's basically meant to.
It strikes me that somehow we should be able to do better with a special purpose thing, much better than a general purpose could give us. But it would be interesting to be proven wrong on that point.
Incidentally, as a matter of results, it has been shown that the program, when you model some specialized things like traveling salesman problem or some of these problems as a constraint satisfaction problem, and solve it on Alice, it has been shown on the average to give as good results as specialized programs for the purpose. So,
oh, that's interesting. Yeah. Especially if it's been verified by somebody other than the author of Alice. Yeah. This is. We should try to see how she does on this kind of constraint.
might be a bit difficult to
But
get
it's
to pronounce.
It's a French program.
Yeah.
Okay.
Yeah, for traveling salesmen, there are fairly good constraints you can use. I mean, I'm sure it depends on the problem.
The problem 3 is also going to be a special case of constraints in some way. So we might be able to return to this subject. And, yeah. Okay. What do you think we ought to do now? That space after comma was pretty clear. But what else do you think we can do to?
Space after make and before maybe. And before maybe.
Let's try spaces around make. See if that does any good. Somebody have a watch? I want to.
11:42.
It's 22.
Okay.
I typed return and nothing happened.
You typed return and nothing happened. That's called time sharing.
I typed in the wrong address.
Okay. Well.
Sorry about that.
Well, 228 was where the E was, so it's a good thing that it didn't allow us space there. Is that right? Okay, this leads to an invisible character.
Okay.
229.
Now, you notice there's no point trying a D after that, because if there was a D there, it would have been put in when the E was, because the two characters are different. The one,
Yeah, that's true.
So,
It's probably not like
if you've got an ED, if you get one for the ED, you automatically get the other one. Because if you one,
Yeah.
Okay.
Yes.
you try
The
it.
past
Yeah.
participle of make is made. Oh, whatever.
Doesn't work either.
ER.
Oh, okay. Ah, right.
Okay. None of those others worked, huh? All right. Well, is there a way for you to sort of let the thing run and put in guesses?
I can keep looking for guesses, yeah. If I just type D again, it goes on and looks to the next guess after that.
I mean, one way to do it might be simply just to go ahead and not care about making bad guesses too much and let the machine keep suggesting stuff. So here it said good. All right. Continue.
We'll leave that there.
Yeah, why not? Good looks good. So, unless somebody else wants to. People, that's...
This gives a plus sign in the first row.
No, there's not much mathematics in that. In there, huh?
I think it's just star on the second last line, so maybe it's plus something else.
Okay. Footnote.
Linear algebra.
No. Right? This is
linear algebra.
linear. Yeah, right. Okay, there's a QE. Is that right?
It seems unlikely.
QE, yeah, QE doesn't go well either.
Unless it's a mathematical.
So that brings up another point.
In which case it would be followed by a D.
Now, a QE is something that brings up another point worth mentioning, and that is that there's also pairs of letters that we know are very unlikely, even though individual letters are there. Okay, so it also if someone wants to automate some of this plausibility thing, they could also have some way of looking at pairs of letters instead of individual letters.
Yeah, actually, I think it was Scientific American, but around 1970 or so, there's an article I took up that talked about just that. It was zeroth order monkeys, first order monkeys, where an nth order monkey is one that considers the probability of a letter occurring after the preceding n-1 letters.
Yeah, that's right. I think it was John, guy from Bell Labs who went to Caltech after, famous scientist. Oh gosh, his name was John, and he did these experiments with randomly generated English text, where you use a Markov process. It says that the states of your text depend on the previous k characters that you've generated, and given those characters, then you know the probability distribution of the next character. So following a Q, for example, if you had only k equals 1, then it would give you very high probability of a U following it, almost total. I guess in English, there's only a few African tribes or something, or a word like Samarkand with a Q in it or something, but mostly it's going to have a U after it, and so it almost surely will generate a U, and then after a U it has a certain probability distribution as to what the next letter is. And then for different values of k, you can generate different orders of text. Same has been tried for music. And that was done, in fact, at Harvard in the 50s, where they fed in, I think it was a few hundred hymns from the Methodist hymnal, and they tried these patterns, and they found out that when you took k equals 6, it would reproduce one of the hymns entirely, because there was only 6 notes would guarantee that the next note would be forced. It would only appear once in the database. Some people used the cray at Livermore to generate English text, and also random Pascal text and random text from a computer manual. The biggest databases they had over there was the documentation for one of their operating systems, and so they generated random documentation. It was really fun. It was a project that they turned in once in 163 class. And so, this kind of data, by the way, you can get just by looking at some files that are already in the computer. For example, things from the news service or something like that. But a dictionary is not the best way to get this frequencies, because it doesn't include carriage returns and punctuation marks and spaces in the right frequency, the right way. Well, now what happened now? The Q is back in.
The Q is already there.
It's okay.
We found the word have.
Have?
Yeah.
That sounds pretty good. There's a capital Z.
Unlikely, but likely.
Oh, that's just, what I would like to do, Kathy, just plunge ahead though, away, and then, we see, my hypothesis is that suppose somebody gave you this whole message, but clobbered every letter with say, 80% probability, 70% probability, but still it would be consistent with ASCII code. So you have a letter that has a bunch of asterisks in it, maybe even a message with asterisks and impossible things. But still, there might be some combination of letters that just strikes you that it has that you do know the truth, even though it's been mostly destroyed. So maybe by plunging ahead.
In that case, it's better to answer no to the question so that you're not constraining things and just remember where they go. Because if you answer yes, then you've constrained it a bit more.
Oh, okay.
Yeah.
Well, what? I don't understand. You don't want to constrain
Every
it?
time, well, if you want to see all the possible words,
Yeah.
then every time you add a word, you add more constraints to the map that you're using.
Yeah. And so, but suppose we don't care if they're.
But that may cancel out possible words later. If you make a
Yeah.
bad guess now, it may cancel out the right guess later on.
Yeah.
Take an extreme example.
Yeah, that's okay. What I was saying is that we might still, even though we make bad mistakes now, it might not be too bad because we're going to throw. We always have this B command that'll take us all the way back to the beginning. So, is there a way to set it up just sort of go?
No, not at the moment.
It's,
Type had several G's.
excuse me? So Dimitri, do you think that you can guess English words fast enough, not being a native speaker? Is
Guess is better than we do.
His guess is very good? I'm not sure if this is discriminating against the people who, of course, you were born in Tanzania. Yeah.
But I've been speaking English almost since I was born.
Because I noticed that when I came back from a sabbatical in Europe, I couldn't play Scrabble anymore competitively because I kept thinking of Norwegian words. And that wouldn't be allowed in the game, and it was interfering with.
You stuck your Norwegian dictionary in there, it would be.
Yeah, you have to allow the thing. Okay, so we got Zig.
The Z was already there, but we added an IG.
Okay, well, see, that doesn't matter. Let's keep on going.
Okay.
See, in other words, it doesn't matter. Maybe the Z will get rid of that, but maybe it will turn out it's about the follies or something. It's not spelled that well. I was not really spelled that way. Last week. Semicolon, that looks pretty good. Probably semicolon, and I think she used a lot of semicolons.
It's run out of words.
It's run out of words, okay. So now we have to put in our own words? What do we do now?
Well, look for some more spaces, I guess.
Spaces, okay.
Yeah.
Okay. Put in spaces everywhere you can. Oh, you have to tell it where to go. It won't just tell you where they go. Yeah.
No, that's right.
Mm-hmm.
Oh, is it?
You have the plain text there.
I have the answer sitting there too. Yeah, I was peeking.
That space led to a left curly brace after the where.
Left curly brace after the where.
Highly.
Sorry.
No?
No, it didn't.
Oh, okay.
Okay.
Okay, so we got Ziggy in here. Yes, we can. People sound good. Sounds good.
We finally can't get a space for the before where, so I guess the only two-letter word that could go there is nowhere. Maybe
Nowhere? Okay, let's try nowhere.
Okay.
Somewhere?
Anywhere.
You
only have two letters, and then you've got two.
So you
Semicolon.
might have to undo the semicolon, but I'll try nowhere first. Okay.
Okay. Wait, in fact, it's only a one thing. Is that right?
No.
What? It's
Could
going
be
to
9, isn't it?
Yeah, that's right.
Could be carriage return line feed.
carriage return line feed is another possibility.
Yes, that would be a likely cause.
Curl of where?
So you want to try carriage return line feed there? Somebody suggested.
Yes.
Okay. Sorry.
Carriage returns and line feeds do follow each other in this computer, so that's another thing that we can. That's another thing. If you have a line feed, it's got to be preceded by a carriage return. If you got a carriage return, it's got to be followed by a line feed in this editor, and that's par for the course. Fair game or whatever the right phrase is. Use.
So that fit.
So that fit, huh? We got a semicolon carriage return line feed in there.
Oh, yeah.
The carriage return isn't there yet.
Oh.
She's putting it in.
I'm just putting the carriage return in now.
Oh, okay. Let's see if it's possible to find out where carriage return and line feed would go.
You can't put a carriage return before the line feed.
Oh, okay, it doesn't like that
line
one.
feed.
Oh, okay. Okay. Now let's see. Okay, Kathy, I'll give you a rest for a minute. Let me show you. I got a printout of another run. Does somebody else have a program that they want to get going on this? No. Meanwhile, nobody. Okay. So let's focus on this, and I'll put this up on the to look at in similar thing which went on when I was trying this. Just to give, so we have two examples to look at. Okay, well, let me just start out with this. The easiest way will be to use these pins maybe. Okay, now this is, I'm not claiming that my program is especially efficient, but it's just slightly different, so they'll give us two things to look at. And I was going blind on this. Let's try to close up on this as good as you can, huh? I'll be pasting up some other ones as we go, so see what we can do. Let's see. So my thing was a slightly different approach, but I just said searching for the probable word space, and it said 5 hits. And so when I have this funny for all character, that means that I don't know anything about it. Can you get even closer? No way. Okay. So this is fine print, and so on the.
Might try using the other board and turning it slightly towards the camera.
Well, he's all set up for that now, so I think it'll be okay. So anyway, I can read it to you. It says searching for probable word the 5 hits, and it found 5 places. Then I tried probable word space which on space. It said no hits. Searching for probable word that, 1 hit. Then I said put in the word that, because all right, and that caused a less than sign, a 9, and a minus sign to come in. A hyphen is conceivable, but the less than sign isn't very good. So then it says backtracking to level 0. Okay, then I looked for the again and started to insert the, and I inserted as many thes as I could, and I started getting I started getting garbage. Okay, so that was the initial thing, and I wasn't getting too far.